NASA recently announced that Voyager 1, the most distant human-made object in the universe, is once again sending usable information to Earth. This marks a significant achievement for NASA engineers, who successfully re-established communication with the spacecraft. Voyager 1, often regarded as humanity's furthest emissary into space, had previously encountered technical issues, transmitting unintelligible code that puzzled scientists. However, a recent revelation regarding the probe's latest findings has sparked widespread intrigue and excitement. Renowned science communicator Bill Nye stirred curiosity when he disclosed that Voyager 1 had detected 300 massive objects in deep space. This discovery not only captivates the imagination of space enthusiasts, but also raises profound questions about the nature and origin of these objects. For nearly half a century, the Voyager missions have provided humanity with some of the earliest and most remarkable glimpses of our solar system. Surprisingly, these missions were not initially designed to last this long. In the 1970s, scientist Michael Minovich proposed a breakthrough idea. Spacecraft could use a planet's gravity to propel themselves further into the solar system, allowing for extended missions without requiring large amounts of fuel. Originally intended to operate for just 5 years, the Voyager missions have far exceeded their expected lifespan. Launched weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were initially tasked with exploring Jupiter and Saturn. They successfully fulfilled this mission, providing humanity with groundbreaking data on these gas giants. However, their journey did not end there. Voyager 2 continued onward, making the first-ever close-up observations of Uranus in 1986 and Neptune in 1989. These extraordinary planetary flybys earned the mission the title of Voyager Grand Tour. Rather than concluding their journey after these planetary encounters, the resilient Voyager spacecraft embarked on a more ambitious mission, exploring the depths of interstellar space. Now, 46 years later, both Voyager 1 and Voyager 2 continue their journey, transmitting valuable scientific data from the farthest reaches of the cosmos. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space. This marked a historic moment as the probe became the first human-made object to venture beyond the influence of the Sun's magnetic field and particles. Interstellar space is the vast region between stars, a realm beyond the solar wind's dominion, a transition akin to stepping out of a bustling city into a serene, star-filled wilderness. The journey continued in 2018 when Voyager 2 also crossed this boundary, reaching an astonishing distance of 17.7 billion kilometers from the Sun. These twin spacecraft remain the only probes to have ventured into interstellar space, pioneering our understanding of this uncharted territory. Their primary role is to study how the interstellar medium interacts with the solar wind emitted by our Sun. NASA's Voyager spacecraft have been instrumental in expanding our knowledge of the heliosphere, a protective bubble that envelopes our solar system. This heliosphere is sculpted by the solar wind, a continuous stream of charged particles ejected by the Sun acting as cosmic reporters. Voyager 1 and Voyager 2 have relayed invaluable data about this celestial shield and its interactions with the interstellar environment. The boundary where these interactions occur is known as the heliopause, marking the official transition from the Sun's influence to the vast expanse of interstellar space. One of the significant findings made by Voyager 1 and Voyager 2 is that cosmic rays, mysterious, high-energy particles, are 3 times more intense beyond the heliopause than within the protective heliosphere. This contrast is akin to stepping from the tranquility of a backyard into the chaotic bustle of a busy city street. NASA scientists have not limited their research to Voyager data alone. They have integrated observations from subsequent missions to create a more comprehensive understanding of the Sun's influence on its cosmic surroundings. One of the most intriguing revelations came last year when Voyager 1 detected a faint, continuous humming sound in interstellar space. Scientists determined that this sound corresponded to vibrations generated by minuscule amounts of gas floating in the void. Nicola Fox, head of NASA's Heliophysics Division, emphasized the importance of the Voyager missions, stating that they have fundamentally transformed our understanding of the Sun and its far-reaching effects in ways that no other spacecraft can. The longevity of the Voyager missions is nothing short of extraordinary. The spacecraft rely on power systems fueled by plutonium, which gradually produces less heat as it decays. This loss of heat poses a critical challenge as the probes have begun losing power. To counteract this, NASA has had to make difficult decisions, shutting down non-essential systems and even some that were initially considered crucial. The heaters designed to keep scientific instruments warm in the freezing depths of space were turned off in an effort to conserve energy. Despite these harsh conditions, All 5 of the spacecraft's instruments have continued functioning since 2019, defying expectations. This has left NASA experts perplexed, as the instruments should have succumbed to the extreme cold. The mystery surrounding the Voyager's resilience only adds to the intrigue surrounding these legendary spacecraft. The inspiring legacy of these pioneering probes has endured for decades, as the twin spacecraft have granted humanity an unprecedented window into the mysteries of space between the stars. Since their launch in 1977, Voyager 1 and Voyager 2 have journeyed farther than any human-made objects in history, pushing the boundaries of space exploration and continuously broadening our understanding of the cosmos. Their contributions extend beyond our own solar system, revealing unexpected and fascinating aspects of the interstellar medium, a realm that was once beyond our reach. These spacecraft, originally designed to explore the outer planets of our solar system, have far exceeded expectations, transforming into interstellar explorers that continue to send back invaluable data even after more than 4 decades of travel. Despite appearing as a calm, glowing celestial body, our Sun is a dynamic nuclear powerhouse hurtling through the galaxy at a staggering speed of 450,000 miles per hour. This immense force of nature is not simply a source of light and warmth. It is an active and volatile sphere of plasma, with tangled and twisted magnetic fields that generate immense bursts of energy. It continuously emits a powerful stream of electrically charged particles known as the solar wind, which travels outward in all directions, influencing planets, moons, and space environments throughout the solar system. However, this solar wind does not simply dissipate into space. Instead, it collides with the interstellar medium, a vast and mysterious mixture of gas and dust remnants from ancient star explosions that drift between the stars. This interaction between the Sun's influence and the surrounding cosmos is not seamless. Rather, it resembles oil and water meeting. Rather than blending smoothly, they create a distinct boundary, forming an invisible yet immensely important structure that protects our planetary neighborhood. The solar wind, in its continuous outward flow, creates a vast protective bubble known as the heliosphere. This immense and complex structure serves as a shield, deflecting harmful cosmic radiation and charged particles from interstellar space. Scientists have long studied this region, seeking to understand how it protects Earth and the rest of our solar system from the harsher environments of deep space. Thanks to data from the Voyager spacecraft, researchers have determined that this heliospheric bubble extends an astonishing 11 billion miles from the Sun at its leading edge. Encompassing the Sun, all 8 planets, and countless celestial objects, including comets and dwarf planets, the heliosphere plays a crucial role in shaping the space environment around us. More than just a passive boundary, it is a dynamic and constantly shifting structure, influenced by solar activity, interstellar pressures, and the ever-changing balance between the Sun's forces and those beyond our solar system. Beyond its fundamental role in defining the edge of our solar system, the heliosphere acts as a vital protective barrier for life on Earth. By acting as a cosmic shield, it prevents a significant portion of harmful cosmic rays and energetic particles from penetrating our solar system, reducing their potential to cause damage to biological systems. Without this protective barrier, life as we know it could be far more vulnerable to dangerous radiation that permeates interstellar space. The shielding effect of the heliosphere ensures that Earth and its neighboring planets remain relatively insulated from the intense cosmic forces at play beyond its boundaries. However, this protective force is not absolute. Some cosmic radiation still makes its way through, influencing planetary atmospheres and even playing a role in the evolution of life over billions of years. Understanding the nature and behavior of the heliosphere is key to unlocking many cosmic mysteries, and this is one of the primary reasons NASA continues to work tirelessly to maintain communication with the Voyager spacecraft. Operating these distant explorers requires innovative solutions that test the limits of human ingenuity. Given their extreme distance, now over 15 billion miles away, sending commands to the Voyager probes is akin to performing surgery on a patient located on the far side of the solar system. Unlike modern spacecraft with advanced computing systems, the Voyagers were built with technology from the 1970s, operating on rudimentary machine language, the most basic form of programming, without an operating system or high-level programming tools. Yet, despite their outdated hardware, these spacecraft continue to function thanks to carefully crafted software updates designed by NASA engineers. Updating the software of the Voyagers is no simple task. Since their launch, the spacecraft have relied on assembly language, a low-level programming method closely related to machine code. This language allows for precise control over the spacecraft's operations, but requires meticulous planning and execution. NASA engineers must craft new instructions in a format that the Voyager hardware can directly interpret, ensuring that even the most minor updates are carefully implemented without errors. Additionally, pseudocode is employed to automate repetitive tasks while conserving memory, optimizing the spacecraft's limited resources to keep them operational. These software updates are not merely about fixing minor glitches. They are vital for the continued survival of the Voyager spacecraft, allowing them to adjust to changing conditions and adapt their operations to maximize efficiency. Despite the incredible distance, extreme cold, and harsh radiation of interstellar space, NASA's ingenuity has allowed the Voyagers to remain operational. These spacecraft continue their mission as silent sentinels of the cosmos, beaming back data from regions of space never before explored. Their journey represents one of humanity's greatest achievements in space exploration, a testament to human curiosity, determination, and perseverance. As Voyager 1 and Voyager 2 continue their epic voyage beyond the boundaries of our solar system, they carry with them a lasting legacy of discovery. Their findings have reshaped our understanding of the universe, proving that even aging spacecraft, long past their expected lifespan, can still unveil new cosmic wonders. The mystery of the 300 massive objects detected by Voyager 1 remains unsolved, but one thing is certain: our journey of exploration has only just begun. These mysterious objects, detected in the depths of space, have sparked numerous questions among scientists. Are they remnants of ancient celestial bodies, interstellar debris, or something entirely unknown? The answers may still be far beyond our reach, but the mere fact that we can detect and study such phenomena from billions of miles away is remarkable. Each discovery by the Voyagers deepens our understanding of the cosmos, raising new questions and challenges for future exploration. As the Voyager probes drift further into the silent abyss, they carry with them more than just scientific instruments. They also bear a symbolic message from Earth. Attached to each spacecraft is a golden record, a time capsule containing sounds, music, and greetings from humanity, a message intended for any extraterrestrial life that may one day encounter them. These golden records serve as an interstellar greeting card, a hopeful attempt to make contact with the unknown and share the essence of life on Earth. These spacecraft, once humble emissaries of a single planet, now serve as cosmic ambassadors, venturing further into the great expanse of interstellar space. The Voyager missions stand as a testament to human ingenuity and the unyielding spirit of exploration. These spacecraft, launched nearly half a century ago, continue to push the boundaries of what we know about the cosmos. Their unexpected longevity has allowed us to gather unprecedented data, not only about the outer planets of our solar system but also about the nature of interstellar space itself. The discovery of 300 massive objects detected by Voyager 1 adds a new layer of mystery, sparking questions about their nature and origin. Are these objects remnants of ancient celestial bodies, interstellar debris, or something entirely unknown? The answers may still be far beyond our reach, but the mere fact that we can detect and study such phenomena from billions of miles away is remarkable. As the Voyagers continue their silent journey into the unknown, they remain symbols of human curiosity and the limitless potential of scientific discovery. These pioneering spacecraft have demonstrated that, even in the vast and seemingly infinite emptiness of space, there is always more to learn, more to explore, and more to discover. Their legacy will continue to inspire generations of scientists, engineers, and dreamers who look to the stars and wonder what lies beyond. The Voyager mission is not just a technological triumph, it is a reminder that the human spirit is boundless, and our quest for knowledge will never cease.